Okay, question 8. Deer mice, not even going to attempt to say that at all, are small mammals living in a variety of habitats ranging from low to high altitude. An investigation was carried out to compare the haemoglobin from two populations of deer mice living at low and high altitudes. Blood samples were taken from both populations and exposed to different levels of oxygen. The percentage of haemoglobin in the blood samples which had oxygen bound to it was measured. Results are shown in the graph. Okay, so we've got a single axis graph, but we have two lines on it. We have, for the dotted line, this is deer mice at high altitude, and the solid is at low. Okay, and then we've got oxygen level to which they were exposed, and then we've got how much haemoglobin as a percentage bound to the oxygen. State one variable that should be controlled when exposing the blood samples to oxygen in order for a valid conclusion to be drawn. Okay, so it said, because it just basically said here, and exposed to different levels of oxygen. So I'm just going to give you the list that was in the mark scheme for this one. Okay, so they went time of exposure, which was what I'd written down in my scribbly answers, so I thought that was reasonable. Temperature, volume of blood. What else do they have? They had surface area of blood exposed. So obviously that's the kind of vessel that you put it in. The age of blood they had down there, which I don't think that's where I would have gone, but they had it as an acceptable one. And they also said pH, okay, because all these impact on haemoglobin uptake. So honestly, time of exposure was what I was expecting you to pull, because that's the one I'd written down when I was going through. And that's the first one that came to mind. Okay, state the oxygen level at which there is the greatest difference in the percentage of haemoglobin bound to oxygen between the two groups. Well, so all I'm looking for is what is the biggest gap in here. So it's quite clearly at this point. It's at 40 units. Okay. Use information from the graph to explain how the deer mice from the population living at a high altitude are adapted to a low oxygen niche. Okay, use information from the graph. That means if you don't put a data point in here or use actual information that's there, you're not going to get the mark. It's quite clear what's happening, that the high altitude mice are actually able to bind more haemoglobin to oxygen at lower levels of oxygen. So that means at higher altitude, where there is less oxygen available, they are still binding more of that as a percentage to their haemoglobin. But you want to pick up data points for this one. So your kind of change at data is probably not this point up here. You know, anything about 80 is not great of a difference. 60 is pretty good. You know, from here you're starting to get a difference between the two. So you could pull that one out. I personally would go for pulling out a specific point. So saying something like at the 40, which you'd already looked at, that at a lower level of oxygen, for example at 40 units, the high altitude mice are able to bind 70% of their haemoglobin to oxygen, whereas the low altitude mice are only binding 50% of their haemoglobin with oxygen. And if you've done that, then you've got a comparison. So you're not going to get the mark just by saying they bind more oxygen to their haemoglobin, because it says using information from the graph. Okay, suggest one, in fact you don't need to know this. It says one physiological adaptation other than differences in haemoglobin that they would have to increase the efficiency of oxygen delivery to cells. No longer part of the course content, don't worry about it at all. There are some obvious things you might think of, like they've got more red blood cells, or they may have better ways to get the oxygen in, so that would be increased oxygenation in the lungs, so bigger lungs basically. But don't worry about it, no longer part of the course. Okay, C. Describe the structure of a deer mouse heart and explain how this allows efficient delivery of oxygen to cells. Well, a deer mouse is a mammal, so I'm looking for you to tell me that you've got 2 atriums, 2 ventricles, okay? And the reason why this is efficient is because there is no mixing of oxygenated, deoxygenated blood. And that's you. Whole question. Okay, let's say ignore B and ignore me waffling around that.